All right, so the next thing we're going to be doing is just evaluating using all this information we found. So cosine of negative pi over 4, this is actually from the last section, but just to refresh our memory. So cosine, I have my unit circle here. If I want to go to negative 4, remember I always start here, but negative means I go clockwise, and that would stop me at negative pi over 4. So my cosine is my x value, and so that will be, it looks like root 2 over 2, because it's your x value. Now B says, name the quadrant in which the angle theta lies in if your sines are negative. That's what that says. Sine of theta is less than 0. And cosine of theta is greater than 0, so that's positive. So let me ask you again. Cosine, is it attached to your x or your y? Well, it's attached to your x. So this is saying my x's are positive and sines are negative. So that means my y's are negative. So what quadrant would I have a positive negative? Well, that would be quadrant 4 right here, right? Because I have positive and negatives. So this is quadrant 4. All right, now I want to know when cosecant is positive, greater than 0, and cosine is negative, because it's less than 0. Remember, cosecant is the reciprocal for sine. So that is attached to your y's, or the other definition is 1 over y, right? Well, your 1's always positive. So this is asking for my y's are positive. And remember, your cosines are attached to your x's, so they're asking where your x's are negative. Well, that would be quadrant 2. All right, so for this one, it says, I want to find the exact value. So that's important, exact, so I don't want any rounding, okay? So if you have a radical, you're going to leave it in terms of a radical. Of the 4 remaining trig functions, if I'm given this, sine of theta is 4 over 5, and cosine of theta is negative 3 over 5. So what I'm going to do is I'm going to give myself a Cartesian plane, and this is saying that my sines are positive, so that means my y's are positive, and this is saying cosine of theta is negative, so that means my x's are negative. And hopefully doing the 2 previous kind of help sink that in. So what quadrant will we have to be in where our x's are negatives but my y's are positive? That means I have to be in the second quadrant. And I'm always going to put my theta near the origin. Always, 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 always. Okay? Remember, that's your reference angle. Okay, so this is saying sine of theta, bringing us back to when we first met, is 4 over 5. Well, sine is opposite over hypotenuse. Well, now cosine of theta is negative 3 over 5. Well, that works because then this piece would be negative 3, right? Because we're in the second quadrant, and my hypotenuse is still 5. So now you have all those missing side lengths. So finding the next 4 will be pretty simple. Tangent of theta, well, that is opposite over adjacent. Just to give you more options, you could have also have said, wait a minute, I also know tangent is sine over cosine, y over x. Well, if you do this, we get the same answer. So whatever your brain likes. For me, I like to visually look at a triangle and do it. So my cosecant, well, I don't even need that triangle because it's just the reciprocal of this. And that is 5 over 4. Secant is just the reciprocal of cosine, which would be negative 5/3. And then cotangent is the reciprocal of tangent, which would be negative 3/4. Or you can use your triangle, right? Cosecant is opposite, hypotenuse over opposite, so that checks out. Secant is hypotenuse over adjacent, that checks out. And cotangent is adjacent over opposite. The next one, now they want us to find the 5 trig functions because they're only giving us 1. All right, but they do tell us where we should be. So for me, I love me a visual. I'm going to be in quadrant 4. And my definition of cosine is adjacent over hypotenuse. Well, how can you find that missing side length? Yes, it's a right triangle, so it has to be Pythagorean theorem. So it says my unknown, so I'll just leave it x, plus the other equals 5 squared. And maybe I should have been better and named it y since, it's a vertical movement, but whatever you'd like. Well, I end up getting, and if I take away that 9 just to save me a little space, I get 16, so I get 4. But you're in the 4th quadrant, so you want to make sure you say negative 4. Because that's just helping you with location. I know we're so used to, wait, we can't have negative lengths, but now we're talking about location. And so now, going back to when we first met, we can list them off just using the definitions. So sine of theta is opposite over hypotenuse. I already have cosine. You could list it if you want, but I'm not going to list it again. Tangent is opposite over adjacent. Then I have to do cosecant, which is just the reciprocal of sine. I have to do secant, which is the reciprocal of cosine, which was given to me. So it's a good way to check your work. Make sure it all pans out. And then cotangent of theta is negative 3/4. And it doesn't matter where you put your negative. If I want to be terribly accurate, because it's just a ratio that's negative, I'll keep it with the 4, but it really doesn't matter. The other thing I really want to make clear, don't forget your thetas when you write this. I will dock you points because this is a function. So if you don't have that input theta, that thing doesn't exist. All right, so don't get lazy on me. See you next time.